Hi, welcome to video 2.2a, Introduction to Differentiation Rules, and this is where we get to use the shortcuts, so you will no longer be using limit definition to find a derivative, nor will you be using your calculator. You'll be using these algebraic shortcuts by hand. So no more using limits. We're looking at basic differentiation rules. Towards the end of this section, we will get to rates of change. So here's what the book calls the constant rule. The derivative of a constant function is 0. Now if you think about that, of course, you have a horizontal line, because if you have y equals a constant, it's a horizontal line. And as that bug travels along that line, of course, its little matchstick will also be horizontal, meaning the slope of that tangent line will be 0. So the derivative of any constant is 0. So the derivative of 7, negative a third, e is a constant, pi is a constant, pi cubed is a constant. The derivative of any constant is 0. This one the book doesn't exactly state per se, but you could think of this one if you want. It'll work later without this theorem. If you think of a line with a slope of m, let's say the slope here is, I don't know, a half. As that bug travels along that line, its matchstick is also going to be parallel to this line of a slope of a half, which means the slope of the matchstick, the slope of the tangent line, will be the slope of the line itself. So the derivative of mx plus b is n. So it's a quick one. If you see that it's a linear function, it's just the slope of the line. Very straightforward. Okay? Next, the power rule, very important rule. If n is a rational number, so n is in the exponent, so we're talking an exponent that is rational. For example, 3 or negative 7 or a half or negative 2/3. Then the function f of x equals x to the n is differentiable, and the derivative of x to the n is n times x to the n minus 1. For f to be differentiable at x equals 0, n must be a number such that x to the n minus 1 is defined on an interval containing 0. Don't worry about that last part. I'm going to go right to this proof so that you can see this proof where they try and prove to you that the derivative of x to the n is equal to n times x to the n minus 1. Supposedly you could be expected to do this on the AP, but I've never seen a question on it, but who knows, this could be the year. So of course they don't use h, they use delta x. That's our limit definition of the derivative. So what we have is, instead of x, we have x plus delta x to the n. Okay, this is f of x plus delta x minus f of x. This, of course, is the binomial expansion theorem. If you take x plus delta x to the n, you will get x to the n times x to the n minus 1 times delta x, etc. And finally, at the very end, you'll have this minus x to the n. That's all over delta x. The x to the n's cancel, and then you're left with this piece right here. Then what happens if you factor out all the delta x's? They don't show you that step, but once these two, the first and the last terms, are gone, every other term has a delta x, which you factor out, which is why this is now just nx to the n minus 1. One of these delta x's is gone, and etc. One of these is gone, and so is the denominator. You now replace all the delta x's by 0. All these terms will disappear, and therefore you'll simply be left with n times x to the n minus 1. So that's the proof. Okay, but it's much easier to use it than to prove it. So basically all that happens is, if you have the derivative of just x, not 5x, not ln x, not just x, to a power of a positive or negative integer or fraction, then what you have is you take that exponent, it comes out in front. As you can see, that exponent n comes out in front. You write your x, and then you subtract 1 from that exponent. Okay, so it's very straightforward. So for example, here, before you actually take the derivative, be careful. You can't take the derivative of 1 over the derivative of x to the 5th. You have to rewrite that expression as the derivative of x to the negative 5. The exponent comes in front, and then you subtract 1 from the exponent. Be careful, because negative 5 minus 1 is negative 6. You could rewrite the answer with a positive exponent. You don't have to. Here's another example. We're going to have to rewrite that as x to the 2/3. The 2/3 comes out in front, and then we're going to have 2/3 minus 1. Now 2/3 minus 1 is 2/3 minus 3/3, which is negative a third. Be careful. You could write it that way. You could write it with a positive exponent. You could put it back into the form it started out in, which is in radical form. Okay, so far we have three theorems. The derivative of a constant is 0. The derivative of y equals mx plus b is the slope of that line m. And the derivative of x to the n is m times x to the n minus 1, where n is a constant. And by the way, a rational constant. Okay. All right, now the constant multiple rule, if f is a differentiable function and c is a real number, then c times f is also differentiable, and the derivative of c times a function is c times the derivative of the function. In other words, you can pull that c on the outside. So the long way of looking at this is I can pull the 3 on the outside and then multiply that by the derivative of x to the 5th, which of course is 5x to the 4th, and that'll give me 15x to the 4th. Now what we're going to do is the shortcut version of this, which is you'll end up multiplying that coefficient by that exponent, as you can see right here. So we multiply the exponent by the coefficient and then subtract 1 from the exponent. Okay, so here's an uglier one, but it's really not that bad. The first thing you have to do is rewrite this as x to the 2/5. And then I take the exponent times the constant. I get negative 4/15 times x to the, and I subtract 5/5 from 2/5 to get negative 3/5. Again, you could leave it with a negative rational exponent, a positive rational exponent, or write it in radical form. Sum and difference rules, very easy. Just like limits, you can break up a sum, so the derivative of the sum of two functions is the sum of the derivatives of each of the functions. Same thing with the difference. So that allows us now to take a polynomial, and now the long version of this is that using the sum and difference rule, it's the derivative of the first term minus the derivative of the second term plus the derivative of the third term, etc. And now the long way of doing that is pull out the constant, pull out the constant, pull out the constant, pull out the constant, and then take the derivatives of those x powers. So that'll be 7 times 3x squared, 4 times 2x to the 1. X is just x to the 1, so remember that's going to be, you can look at it in many ways, but you can look at it as 1 times x to the 0, which is 1 times 1. Or you can look at it as a linear function where the slope is 1, so the derivative is 1. And of course, don't forget the derivative of a constant is 0. And then you just rewrite it by simplifying the coefficients and not bothering writing the 0. So here's another example. Again, you have to rewrite each term as x to a power. So that's x, 7 times x to the third. That's 5 times x to the half. This you would reduce. This is x to the negative a third. Be careful when you bring that up that you make the exponent negative. Same thing here, to the negative 2/5. And then very simply multiply the exponent by the coefficient, subtract 1 from the exponent. Same thing, same thing, same thing. And that's the end of video 2.2a.